Assalamualaikum and greetings everyone. Today I will present my innovation project regarding revolutionizing high water production well coated polymer microsphere innovation. Before starting this presentation, let me introduce our group members. The team comprised of me, Mokhammad Fikri and Miss Nabilla Afzan, supervised under Dr. Iskandar Dzulkarnain. Now, I will briefly showcase background of study in my project. So, high water cut wells is mainly caused by reservoirs heterogeneity, which is due to the long-term erosion of the high permeability layers by water injection. Resulting of this problem leads to water breakthrough into producing wells, which occur along the highly permeable channels, which is called thief zones in water-bearing sandstone layer. Thus, injection of polymeric microsphere, which is a chemical treatment, acts as a plugging agent will be introduced to mitigate excessive water production in high water cut wells for water shut-off operation. There are three problem statements for this project. Firstly, it is important to note that there are no comprehensive studies on the coated microsphere for conformance control. Thus, further research is needed to ensure the plugging performance under Malaysia's reservoir setting. Secondly, researchers in conformance control make limited study to relate the storage G' and loss G" modulus with the lodging of the gel at the pore trough of thief zone. Hence, it is important to study the impact of G' and G" factor of the coated polymer with PGTMO including the flow point to ensure the effectiveness of the plugging agent for a successful water shut-off operation. Lastly, high swelling kinetics of polymer disrupts effectiveness of plugging performance of polymer and also prevents deep conformance control. Hence, polymer will be coated with different concentrations of PGTMO to control the swelling rate and resistance of the gel in reaching desired depth. Objectives of this project are divided into three parts. Firstly, to synthesize a novel combination of coating and polymer system and determine the gel strength with swelling capability and subsurface condition. Secondly, to identify the storage and loss modulus with flow point of polymeric microsphere at different coating concentration in reservoir setting. Lastly, to analyze the rheological behavior of the polymer at static and dynamic reservoir setting. Moving on to the novelty and uniqueness of this project, firstly, a novel coating and polymer system is synthesized to effectively adapt to well AS03 located in offshore Peninsular Malaysia's reservoir setting. The reservoir setting comprised with 80% water cut percentage, temperature of 60 Celsius with 11,170 parts per million and 33,950 ppm salinity of synthetic formation water FW and seawater SW respectively with minimum of 100 millidarcy permeability water bedding zone. The behavior of the microsphere with various polymer concentrations synthesized from acrylamide-based monomers coated with different PGTMO concentration is capable to perform at reservoir temperature of 60 Celsius under static and dynamic condition. Next, the benefits to intended users and society. This project consists of a chemical treatment which helps in reducing excessive water production as a plugging agent in oil and gas industry. Secondly, more effective and affordable since it only requires 6% PGTMO coating, which is the optimum concentration to coat the polymeric microsphere compared to mechanical treatment. And lastly, results from experimental approach showed stability of the coated polymer up to 4 days under constant heating of 60 Celsius for both saline water with aid from Sedan's gel coat and swelling capacity index. Moving to commercialization potential, the coated polymeric microsphere with PGTMO capability at reservoir conditions in delaying the swelling time of the polymer. Secondly, impact of G' and G" factor which affect the effectiveness of the blocking agent for a successful water shut-off operation. Thirdly, Newtonian fluid behavior of coated polymer serves better injectivity of the polymer reaching deeper into the reservoir at increasing temperature compared to polymer with no PGTMO coating. Lastly, proposed optimum coating concentration of 6% is the good choice overall when implementing coated polymeric microsphere as a plugging agent for water shut-off operations. In conclusion, polymeric microsphere with 6% coating concentration will be deployed for deep conformance control and water shut-off applications in high water cut wells to reduce excessive water production. Hence, coated polymer will be able to penetrate into the pore networks while withstand shearing during injection to desired depth and efficiently plug the pores of thief zone while maintaining its barrier shape as the G' and G" moduli of the polymer was assessed beforehand.